So, go back, the Ralston Valley website.
Okay. Ralston Valley High School website.
Yes.
According to
Hold on. It's doing its thing. Let's see.
Okay, and then academics, teacher websites. And then go to the department math. Go to the top.
It's Hamilton, right?
Yeah, Hambleton. Unit 2, quadratics on the left side. And then go to solving systems of equations worksheet. There we are.
Okay. All right.
Focusing question.
All right. What two methods have they taught you to solve a system of equations?
Well, you can try to eliminate a variable. It's the first step. I don't know what method that is.
That's elimination. What's another method?
Isn't there like substitution after you?
That's the other method.
Okay.
So those are the two methods you're looking for. Okay. Now, elimination is used more when you're looking at standard format. And neither of these first two problems are in standard format.
Okay.
However, the easy thing about these first two problems is that those y's are the same.
Right.
So what can I write?
Well, in the system of equations, you're trying to, the answer is going to come out as a.
Those y's are the same. What can I say about the x's?
That they're different because
Well, they're equal, not different.
Oh, that whole entire, yeah.
In other words, 6x equals 3x squared. Okay.
Yeah.
Now, solving this is, believe it or not, a little tricky. You don't want to divide both sides by x.
Okay.
And I'll explain why in a moment, but what you want to do is put everything on one side.
How do I do that?
And now you want to factor out the greatest common factor. Now you're going to get your two solutions. What are your two solutions?
Minus 6x is, well, is it just, well, 3x squared minus 6x, isn't that?
Hold on. Don't go backwards. There's a reason we went from that step to that step.
Oh, okay.
Because once you get to this last step, you can say that you have two things multiplied together that are equal to 0. Therefore, each thing is equal to 0.
Mm-hmm.
So what's x equal to?
Well, it could be equal to 1.
No. Either that's equal to 0 or that's equal to 0.
Oh,
If
okay.
x is equal to 0, what is x equal to?
0. Well,
If x minus 2 equals 0, what is x equal to?
2.
That's how you do those.
Oh, okay.
Don't ignore the fundamental property of algebra. The most important property you can take away from algebra is that two things multiplied together equals 0. Set each one of them equal to 0.
All right.
Number 2 is basically the same thing. Give me an equation I can write. In other words, that y is equal to that y. So what else is true?
I'm not sure to say because this one has more.
No, it really doesn't. What you're doing is setting the y's equal to one another.
Okay.
In other words, this is a system of equation. This is not two independent equations. Either one of these. That's a system of equation. That's a system of equation. When you have a system of equations, that y equals that y, and that x equals that x. If this y equals the other y, then by definition, x squared plus 5 equals minus 3x plus 3. In other words, that's what I'm trying to get you to see, is that over here I had y equals one thing, y equals another thing, therefore 6x equals 3x squared. And then you solve that system. Well, same thing here. I had y equals that thing, and I had y equal that thing, therefore that thing equals that thing.
All right.
Now, let's solve this equation, because we're not done.
All right.
Solve that.
So we start off by taking 3 away from 5 or 5 away from 3.
Okay.
Okay. And then maybe we should have taken 5 away from 3 because
No, you actually did it correctly. Here's what's governing your thinking. What you're really going to do is you're going to put everything on one side of the equation and you're going to put 0 on the other side.
Uh-huh.
Now,
what I want to do is
you're thinking you want this to have a positive coefficient.
Uh-huh.
You want it to have a negative coefficient. You want to have it a positive coefficient. So it's on the right side. In other words, it's on the correct side. So if I leave that over there and bring everything else over, I get this. Now, this is the standard format for a quadratic.
Wait, isn't it -2 though, or is it cross?
I think it was positive. It was positive. It was positive too. Okay?
Okay.
Now that can be factored. In other words, now that I have it in standard format and it's equal to 0, if I can factor it, then I got two things multiplied together equals 0.
Uh-huh.
Does it factor?
Two things multiplied together. So we would start off with the x's and then plus minus on both of them.
Not plus minus. This tells you that both signs are the same.
Oh, okay. So both positive, both plus.
This one tells you both of them are positive.
Mm-hmm.
Once you know they're both the same. And now you're just looking for factors of 2.
Okay, which is 2 and 1. Those are the only ones.
Okay, so what's my solution?
X, well, when we put it as a coordinate, that's what my teacher was, I thought I heard you talking about.
You don't want it as a coordinate. Forget that.
Okay.
We have an algebraic equation here that we can solve. So
Okay.
we don't have to do it graphically. Nowhere in here does it does say verify by graphing on your calculator. We'll get to that in a second. But we want to know how to solve this algebraically. Again, you're looking at the most important principle in algebra. 2 things multiplied together equals 0.
Uh-huh. So it's 2 and 1, right?
No. What makes x plus 2 equal 0?
-2.
Ah, it's -2. What's the other answer?
-1.
In other words, what you're trying to do is figure out what makes that 0.
Uh-huh.
And you're also trying to figure out what makes that 0.
So it's different than a normal quadratic.
No, it isn't. It's exactly the same as a normal quadratic.
Oh, okay.
Okay. Now, we're not quite done. And I omitted this on the first problem because I forgot to see it. But if you read the instructions, it says solve for x and y. Well, let's still look at problem number 2. I solved for x, and I got 2 solutions. X equal -2 and x equal -1. Now tell me what y is. When x equal -2, what is y?
6, 9.
No, yeah, very good. My mistake. When x equal -1, what is y?
6.
Okay. Now, let's go back to and that's the complete solution. Okay. Well, no, it's not really. They said then verify your answer by graphing on your calculator. What kind of calculator do you have, Nate? You have a TI what?
Inspire.
An Inspire. Okay, cool. Go to your graphing calculator.
All right, give me 1 second. Dad, do you have a, I should have one.
Well, if you don't have your calculator, that's okay.
Yeah, I have it. It's just out of battery from today. We were using it, so I have to charge it.
All right.
And I don't cable it, so I'll find that later.
Let's talk about how that would graph. That is a parabola.
Uh-huh.
Okay. I know its x-intercepts are at -2 and -1. There's -1. There's -2. I also know it opens up. So it must look something like that.
Yeah.
Excuse me. That is not correct.
It does look like the kind of what we were seeing on our calculator.
No, I just realized what I did here. Hold on a second. If you graph these independently, you're going to get, that's the first one. That's the parabola shifted up vertically by 5 units. If you graph the second function, you're going to get something that looks like that, straight line.
Mm-hmm.
These two solutions are where these two lines cross. In other words, that point right there is minus 1, 6, and this point up here is minus 2, 9.
Oh, okay.
Okay? In other words, that is a parabola. That is a straight line. And the solution to those two equations lies where they intersect, if we're going to look at it graphically.
Yeah, and so to check if the graphically, we have to graph the parabola and the straight line and the points, the solutions.
Yeah, you have an inspire, right? So just put in this function as function 1, put in that function as another function, you'll get something that looks like that.
Yeah.
And put your cursor over the intersection point and you should get your solution, which the first one you're going to see is x equal minus 1, y equal 6. Second one you're going to see is x equal minus 2, y equal 9.
Okay.
Okay. Now, let's go back to the first one. You really need your graphing calculator to do these, but let's look at the first one. If I graph that, it's a straight line with a slope of 6 that goes through the origin.
Uh-huh.
If I graph this, that's a parabola. It's a narrow parabola that also goes through the origin. So the solution to this system of equations should come right there and right there.
Yep.
Well, let's go back and see what we had. We had 3x squared equals 6x, which means 3x squared minus 6x equals 0, which means we had 3x times x minus 2 equals 0. So we had x equals 0 and x equal 2. Okay, well, there's the x equals 0. When x equals 0, use either equation and tell me what y is. In other words, y equals 6x. So when x equals 0, what is y?
0.
And when x equal 2, what is y?
Like 9.
Use this equation. Y equals
12.
Okay. There's your two solutions. In other words, they want you to solve for x and y. Okay. So on this first problem, x equals 0, y equals 0. That's one solution. Second solution is x equal 2, y equal 12. And then when you verify it on your calculator, you're going to get these two graphs. And wherever they intersect should match your two solutions. In other words, they intersect at x equals 0, y equals 0. And they also intersect at x equal 2, y equal 12. So both of these two problems are pretty much the same. We solve a quadratic that allows us to algebraically solve for both x and y. And then if we happen to graph each function, we're going to see that they intersect at our solution that we came up with algebraically.
Okay.
Okay. It's funny, I saw the upper half of that line on number 3, and I said to myself, that's an integral sign. An integral sign is like that. That's calculus. And
Yeah.
this was what I was seeing only on my screen, was right there. And I said, what the heck are you doing calculus for? But it's not. All right. Now, when should you use substitution and when should you use elimination? Okay. Let me clarify. This is the only time you should use elimination, is if you have two equations that look like this. In other words, if you have, excuse me, that's a Y. In other words, if you have your X and your Y on the same side, and you have your number on the other side, that's where you should use elimination. And so far, they haven't given us one like that. And number 3 isn't one like that either. Number 3, we're going to use substitution. The reason we're going to use substitution is because they have given us one function that is fully defined in terms of y or x.
Mm-hmm.
That one right there is the only one. If I look at number 4, that one is fully defined in terms of y. When you have one of the two equations fully defined in terms of one variable, it doesn't really matter whether it's x or y, but if it's fully defined in terms of one variable, that's perfect for substitution.
Okay.
So let's use substitution here. What?
The equations that we went over previously were both defined.
Yes. That's another place you use substitution. In other words, so far we have not encountered where they were both in standard format, which is the only place I use elimination. In other words, let me give you just what I'm talking about. There's two equations, two unknowns. Neither one of them is defined in terms of one variable, correct?
Correct.
But I can use elimination by adding the two equations together and solving it nearly instantly. Y equal 2. See how I did it?
Yeah, that was fast.
That's the preferable way to do it if they give it to you in standard format. That's in standard format. That's in standard format. So far, they have not given us one like that. So anything other than two standard format equations, you're going to use substitution. Okay? Well, this one, y is fully defined. So let's substitute what it says y is equal to into the second equation. So tell me what I'm going to write. What goes in the parentheses?
Y.
There's what goes inside the parentheses is y.
Oh, x squared plus 4x minus 11.
Okay, now the advantage of doing that is that now you have one equation and only one variable. Notice you got rid of all the y's.
Mm-hmm.
And when you have one equation and one variable, you can definitely solve it. It's going to become a quadratic that you can solve. Okay, what's the next step?
We could FOIL it, or there's no foiling. We could just multiply it all by -2 and then,
Distribute it.
yeah.
That give you?
-2x squared, -8x, and -22.
-2 times -11 is what?
Oh, 22. Positive 22.
Makes a big difference. Okay?
Yeah.
Now, what we want to do is we're looking at a normal quadratic. So we want to gather all like terms together. And we want to put everything on the same side and leave 0 on the other.
Mm-hmm. So we -8 from 22 and we add.
Hold on. The very first step is to see what the sign on that coefficient is. What is the coefficient to that term I just circled?
-2.
-2. We don't like negative coefficients on our x squared term. We prefer them to be positive. So let's gather everything on the right side. If I move that 2x squared over to the right, it's going to be a plus 2x squared.
Yeah.
Okay, now let's gather these terms. What's 12x minus 8x?
4x.
What if I move it to the other side of the equation? What does it become?
-4x.
And now let's gather all of our numbers. Let's put that plus 22 and our -8, and let's put it all on the right side.
-30.
And that's all equal to 0. Now we have a normal looking quadratic that we can solve quite easily. What's the first step for solving that quadratic?
Well, we find what multiplies into.
Hold on. Always make a quadratic as simple as you possibly can. Well, this is complicated because it has something other than a 1 as that coefficient.
Yeah.
So how about we factor out a 2?
Okay, so x, in parentheses x, minus.
That's how you factor out a 2.
Yeah.
Okay? The key being is that after you factored it out, make sure that you can go back the other way. If I remultiply this together, do I get what I started with?
Yes.
Okay, good. Now I can just get rid of that 2 because I can divide both sides by 2. 0 divided by 2 is still 0. So I end up with 0 up at the top. I end up with 0 equals x squared minus 2x minus 15. Now that becomes rather easy to factor. And the reason it's easy to factor is because the x squared component of it has a coefficient of 1, which is what you want. The moment it gets to be something other than 1, it's difficult to factor.
Yeah.
So how do you factor that? What does x squared minus 2x minus 15 factor into?
X minus 2.
No. I don't want you to do it that way. What you're trying to do is figure out one term and then figure out another term. That is not the way you factor. The way you factor is you split up the x squared term, then you figure out the signs of both terms. It's got to be plus minus, because that's the only way I could produce a minus 15, is if the signs are opposite.
Uh-huh.
Now I'm looking for factors of 15 that subtract to the number 2. Well, that's 5 and 3. I put the bigger of those factors with the sign of the middle term. Put the other factor over there. There's my solution. In other words, we've taken this complicated looking problem and we've got it down to a pretty easy solution. One case, so I've got 0 equals x plus 3 times x minus 5. Tell me what my x's are.
3 and 5. 3 and negative 5. Oh no.
Almost. It's always the opposite of what you're looking at. So
yeah, negative 3 and positive 5.
Okay. Now, again, that doesn't answer the whole question. The whole question said, what are x and y? So, how do we figure out what y is when x is negative 3?
We substitute it in for x.
Yeah, and we can do it there, which looks like it could be the easiest, but not really. Notice that if we substitute negative 3 in for that, we get some pretty big numbers. We get 9 times 10, which is 90, minus 45 plus 1. What if we use that one right there?
It'll equal 9 or 10.
Well, let's solve for y first. So we get y equal 4x minus 2. And now we can plug in real easily. And you're right. Y equals 4 times negative 3, which is negative 12. Minus 2 means y equal minus 14. That is one solution. The second solution, plug in x equal 5. What do you get?
20 minus 2?
18. Those are your two solutions. And that's the way you're going to do all of these.
Okay.
No, it's not the way you're going to do all of them, because so far they haven't given us one that you can use elimination on yet. But they will.
Maybe we haven't gotten there yet.
They don't do it on this page. Okay, so what do I got to do to go to the next page?
Go to back to the website. So click back, yeah. And I guess we can just go do some more problems related to this. So keep scrolling down. That's the one we just did, and that's a book work. Can we go back to the October 22nd one and click answer?
Or I can make some up. In other words, I don't.
Yeah. If you could do that and then make up ones that are both standard forms so that I can learn that.
I can definitely do that. Two standard format. Notice what standard format is. The x and the y are on the left side, the numbers on the right side. When you have two that are in standard format, elimination is going to be the easiest way to do it. And the only two things you're allowed to do are add or subtract these two equations.
Okay.
How am I going to eliminate a variable? By adding or subtracting?
Adding.
It's one way. Actually, you would also eliminate one by subtracting, but so when I add these two equations, what do I get?
X equals 20.
2x equals
2x equals 20. Yeah, correct.
Which means x equals 10 When x equals 10, what does y equal?
0.
And that works for both of them. That is a solution for that. That is a solution for that.
Okay.
Okay? So that's one. Very simple one. Let's do another one. Two totally separate equations. By that I mean that one is not a multiple of the other. We'll get to that in a second. When you are solving a system of equations, they have to be completely independent from one another. They cannot just be, I'll cover that. Let's solve this one first. Can I eliminate a variable by adding or subtracting these two equations?
No.
Okay, there's another thing you're allowed to do. You're allowed to take each equation and do anything you want to the left side as long as you do it to the right side.
Okay.
Can I do anything to the top equation that's going to accomplish my purpose of being able to add or subtract the two equations and eliminate a variable?
Well, we can't do that on the right
How
side.
about I multiply it by 2?
Okay.
Which gives me 2x plus 6y equals 14. You have to multiply both sides.
And then if we add those together, it equals just
Now you get
11y plus 26, or equals 26.
which means y equals 26 divided by 11. And then the moment you have solved for one variable, no matter which one, doesn't matter whether it's x or y, the moment you have solved for one variable, you can go back into whatever your simplest equation is and solve for the other variable. In other words, in this case, my simplest equation appears to be that very first one. So I'm going to substitute 26 over 11. So x equals 7 minus 26 over 11 times 3. See how I did that? Okay. And that would be your x value. Whenever y is 26 over 11, x is whatever that number is. And there's your two solutions.
Okay.
So I personally prefer elimination. It's the far easier method. Now, occasionally you get some strange things. What if I give you this? You have to realize that not all systems of equations give you a solution. What if I gave you these two equations? It's in standard format.
Well, it's impossible to figure out what x and y are going to be because the answer is
no solution.
Yeah.
If I subtract those two equations, I get 0 on the left side, I get 1 on the right. Whenever you get one number equals a different number, that tells you you do not have a system of equations that will produce a solution. So there's no solution. Whenever you try to solve it, you get one number equals another, that's no solution. Now, there's another funky situation where one equation is strictly a multiple of the other equation. That looks like it gives you two equations and two unknowns, but it really doesn't. You're really looking at one equation and two unknowns. If you try to solve this by any means, let's say we multiply the top by 2, And then we subtract the two equations. We get 0 equals 0. And whenever you get one number equals the same number, that is an infinite number of solutions. So you've got three possibilities on whenever you have a system of equations. Is you can have an exact solution, which is mainly what we've been dealing with, where you have a specific x and a specific y. You can have no solution, which is where you have one number equals another number. And you can have infinite number of solutions, which is where you have one number equals the same number. And those are three completely different possibilities that you might encounter when you're dealing with a system of two equations. Now, let me give you this. What method are you going to use to solve this?
Substitution.
Correct, because you have one equation that's fully solved in terms of one variable. So tell me what to write.
3x equals 10.
Well, x plus 2x equals 10. Okay, so x equals 10 thirds. And then once you solve for x, you know y is 2x. So if x equals 10 thirds, y must be 20 thirds. Okay, so that's what tells you whether to use substitution or elimination, is what format they're in. Now, the initial problems they gave you were, they gave you two equations, both defined in terms of y. In other words, they gave you something like this, and then they gave you something like this. Well, here they give you both equations fully defined in terms of y. And the thing is that that y is the same as that y. And if that's true, then that is equal to that. So
Yeah.
I can immediately turn it into a single equation and one variable. The moment I let those two equal to one another, I've got only one equation, only one variable. You can always solve those.
Okay.
Okay. And that's really the only, and I noticed that some of them they gave you were quadratics, some of them were not. Doesn't matter. It matters a little bit. If, well, no, when they give you a mixture of quadratics and linears, they don't do it in standard format, so it doesn't really matter for you.
Okay.
Let me give you one more. Standard format or other?
This would be other.
No, standard format. The x and the y are on the left side, the numbers on the right.
Yeah.
Can we immediately solve this by elimination?
No.
No, we cannot eliminate a variable. But don't forget this option you have of being able to multiply both sides of the equation by something. Well, what if I multiply the top by -3, and I multiply the bottom by plus 2. Call that equation 1, that equation 2. My new equation 1.
It's going to be, are we going to subtract them from each other? Or?
Now I'm going to multiply the left and the right side by minus 3.
6x minus 9y equals negative 15.
Now do the second one.
6x minus 10y equals 24.
Now notice what we're looking at. We can solve that by just adding the two equations.
Negative 19y equals 9.
So y equals minus 9 divided by 19. Now, once you solve for y, it's relatively easy to solve for x. In other words, you can go back into any of the equations. I've got 4 equations on my page. Usually use the simplest one. That's the simplest. So I have solved for y. I'm going to substitute it and then solve for x using that first simple equation, not counting that or that. In other words, use the smallest numbers possible.
Okay.
Okay? So there was a situation where we had everything in standard format, but we still had to manipulate not just one of the equations, but both of them in order to get it into a convenient position where we would be able to eliminate a variable. And as you've probably figured out, you're dealing with lowest common denominator. In other words, I'm trying to make 2 and 3 match up. So what's the lowest common denominator? 6. So how do I turn this into a 6? I multiply it by 3. How do I turn that into a 6? I multiply it by 2. If I want to make sure I'm doing addition and not subtraction, I'll multiply one of them by a negative number.
Okay.
So that I have negative 6 and plus 6. Now I can add the two equations, and addition is always easier than subtraction. So whenever you're doing these, you want to make sure that you get it, if possible, into an addition problem. Okay, in other words, if I have this, and I also have this, I can eliminate a variable immediately by subtraction. And that is the fastest way to do it. You get y equal 4, one step.
Okay.
But even in this problem, you could say, well, let's multiply the top or the bottom by negative 1. So let's make that a negative 2x, make it a negative 2y, let's make it a negative 6. And now addition is better than subtraction. So I'm going to add everything. Well, those get eliminated. This becomes y equal 4. So I get the same answer. It's just that most people are a lot more comfortable with addition than they are subtraction. It's just that sometimes subtraction is perfect all by itself. In other words, when I had this, I don't need to turn it into a multiplication problem. Because all I need to do is subtract the 2, and the x's go away, and this turns into y. So sometimes subtraction is absolutely the way to go, but most of the time you're going to be better off, especially if you have to manipulate one of the functions, you're going to be better off doing it in a way that results such that you can add the two functions, not subtract them.
Yeah.
similar to if I have this problem here, I don't do that as a subtraction problem. I turn it into an addition problem. Well, here's the subtraction sign. So I change that, and then I change the sign of what was being subtracted. So now it's an addition problem. Minus 9 plus a minus 7. Nobody misses that. But when it's in that original format where it's minus 9 minus 7, I can't tell you. Half my students would miss that. If I leave it like this, that drives people crazy.
Yeah.
So it's always better to be adding rather than subtracting. And that includes when you have a system of equations.
All right.
Most systems of equations are two linear equations where one's going to graph like that, the other's going to graph like that. You're going to have one solution only, x and y. They started you off with quadratic equations combined with a linear equation. And in these, you have two solutions. You have an x sub 1 and a y sub 1. And you also have this solution down there, which is x sub 2, y sub 2. So depending on the type of equations that you have a system of, depends on how many solutions you're going to have. If I give you a circle and a line, you're going to have two solutions, one right there and one right there, and both of them are going to have an x and a y coordinate. If I give you a circle and a parabola, how many solutions are you going to have?
1, 2, 3, 4.
Exactly. 1, 2, 3, 4. So by knowing what the graph looks like, it gives you a bit of an idea as to how many solutions you're looking for. Solutions are always where they intersect. In other words, a circle and a parabola doesn't have to produce 4 solutions. It could have this solution, where I've got 1, 2, 3, where this is tangent down here. That parabola is tangent to the circle. By that I mean it touches it only in one spot. So all of these solutions will be revealed when you go to solve it. You don't really have to know graphically what it looks like. You just have to do the algebra. And as long as you do the algebra, all of these solutions will come out. For example, let's solve this system of equations.
Okay. Well, x equals 2.
Actually not. X equal plus or minus 2.
Yeah.
So when x equal plus 2, what's y equal to?
5.
When x equal minus 2, what's y equal to?
1.
Those are my two solutions.
Okay.
And you better not ignore that one. You will lose half credit.
Okay. Plus minus.
Now I could have done this a little different method, and I could have used substitution the whole way. If I'm going to use substitution, this is the one that's fully defined, right?
Yes.
So, well, I can't do that. In other words, I don't have a y. in the first one. So if I'm going to fully define this one, I better fully define it in terms of x. So x is equal to y minus 3, correct?
Uh-huh.
Now I can substitute. So I've got y minus 3 squared equals 4. Now I can solve that for y. Once I solve it for y, I'll solve that for x. Now, to solve that for y is a little tricky. You take square root of both sides. Y minus 3 equals plus or minus 2. And now y equals 3 plus 2. Or y equals 3 minus 2. Notice we get the same solutions we got when we did it the other way. Y equals 5 and 1. And then x equal 2. So the system of equations, you have a lot of choice on them. And the most important choice is the very first one you make as to which method you're going to use to solve it.
Okay.
Okay? Nate, I will let you go. You have a good day, and I will talk to you next time.
You too. Thank you.
Bye.